today's event. Welcome back to those of you who have already joined some of our sessions within this series. So before we introduce today's session and speaker, I'd like to welcome you to check in using the details on the screen in front of you. I'll paste these into the chat as well. But the point of checking in is not only to get access to resources and information relating to similar topics that we run at the reactor, but as many of you will know, throughout the series we have a giveaway for participants who attend a minimum of 4 sessions or more in this 8-part series. So to receive a certification voucher for free, which is usually valued at around $165, you can be in with the chance of receiving this if you check in for the events that you attend. So the information is there on the screen in front of you to do so. So if we look at our code of conduct very briefly before we get started. So this is just a reminder to everyone who is with us today, and just to be aware of one another, welcoming and respectful throughout. It's an inclusive environment that we have at all reactor sessions. And so just to really bear that in mind and be understanding of any differences of opinions that we may see throughout the chat or through any Q&A that we have as well. So I'd like to introduce our speaker for today. Dmitry is joining us, and Dmitry works as a cloud developer advocate at Microsoft and has been with Microsoft over the last 13 years, so has a wealth of experience with him. So we're really excited to have Dmitry with us today. And this session will run over the next 60 minutes. It is being recorded and will be available to watch on demand. If you do have any questions, do feel free to post them into the chat. While you might be muted today, we do encourage you to get as involved as you'd like to through the chat. So I'll be keeping an eye on that throughout. So without further ado, Dmitry, I'll hand over to you.
Thank you so much, Emma. I think I will start by telling you what Cloud Developer Advocate is, just in case you don't know, because it looks like it's quite a rare profession. What I do at Microsoft is I help develop some content and deliver some talks. So it's making people aware of our technology and also receiving feedback. Because for people developing our products, in Redmond, it's not always like clear what are the demands, like what should be the best way to use the product. So I pass this feedback back to our product team. So in case you are not happy with some Microsoft technology, you know whom to contact. You can always let me or my colleagues know, and we are really happy to pass this feedback back to our development teams. And what I do, I work mostly with universities, with higher education, making sure that our technologies are well suited for use in academia, in research projects, and so on. I also teach in 3 universities in Moscow, where I live, and that's why I more or less see from inside how education works. And in my spare time, I like doing some science art, creating some beautiful things with programming, and that's something I will be talking about today. I will share one of my cool techniques so that you would be able to also create nice portraits, cognitive portraits, I call them, from a series of photographs. So the main topic of today's talk is Microsoft Face API. As you have heard probably on one of the previous sessions, in Microsoft Cloud, there are a lot of things if you want to do artificial intelligence. Because cloud is essentially a collection of compute resources. You can, of course, use cloud resources just to train your neural network models, to collect data, large amounts of data, and so on. But in addition to that, cloud also provides some simple building blocks which you can use inside your systems. And that is something that we call democratization of artificial intelligence, because things that were very complex to do a few years ago now become available to developers as a simple service. And those services are called cognitive services. They are kind of top level in this hierarchy here. So there are services that can handle tasks related to computer vision, such as detecting objects, describing pictures, seeing what's there in the picture, and dealing with faces on pictures. That is something we'll be talking about today. And also there are services that can deal with speech, convert speech to text, text to speech, do speech translation, and so on. There are services related to language. Those are quite interesting, and we'll be talking more about them next week. Next week, we'll talk about how you can use cognitive services to extract meaningful information from COVID scientific papers, which is like very important and useful topic nowadays, and so on. So there are several services like that, and we will focus today on the vision part of the story. There are resources available for you if you want to learn more about cognitive services. You can always do that. The easiest way to start, I will switch to my browser and show you what is the easiest way to start. We can go to microsoft.com/cognitive, and here we have the list of all cognitive services. I need to scroll a little bit down, and here they are. So there are decision, language, speech, and vision. And we will go with vision today. And inside vision, there are services: computer vision, custom vision, face API, form recognizer, video indexer. That's it. So what's the difference between them? Computer vision is trained for generic computer vision tasks like detecting common objects. You can show it, you can give it the picture, and it will give you back a lot of information about this picture. Let me actually quickly show you, because we have the whole hour. I can show you many beautiful things during an hour. So here in computer vision, you can in fact see what the computer sees on the picture. For example, this picture, you can see that it detects people, it detects notebook, sneakers, and different seating facilities. And as a developer, you are getting back this information in the JSON format. So you can pretty much call a function in the cloud and get back this information. You can also here upload your own photograph if you want. Let me do that. I will upload my photograph here. And you can see that it says that it's a person. And what else? What's else interesting here? Gender, age 49, gender male. And even it gives you the textual description of the picture. You see, it says Dmitry Soshnikov holding a sign. Strangely enough, cognitive services recognize me by name. I am really proud of that. So that was computer vision. Then there is also custom vision. You can train it to detect some custom objects that you can upload several photographs, and the computer will detect specific objects for you. Form recognizer is kind of OCR service which can convert text inside forms into structured form, into real text, and for storage into the database. And Face API deals with faces. That is something we will be talking about today. So inside Face API, we have several functions. Like one of them is face detection. Face detection is the most obvious one. You just like pass it a photograph, and it detects faces, their attributes like hair, hair color, position of the head. Like it can detect when you rotate your head, you can detect all the angles. Facial hair, whether it has makeup or not, whether you have glasses. It can detect emotions as well, accessories, quite a lot of interesting things. And also facial landmarks, like coordinates of all main points on your face, like pupil left, pupil right. You can see a lot of information here. And again, all that you can receive as a developer in a JSON format when you call this service through the cloud. Other functions of Face API is face verification. You can pass it like two photographs, and it will detect whether it is the same face or not. And also it can do things like you can train it to detect certain people. Like if you want to organize, for example, your family album, that is something I've been doing. You can upload several photographs of each of your family members. It will remember them. And then on the photographs, it will detect specific people, so that you can easily sort your album according to different family members. So those look like a pretty cool technology to use. So let's see how we can use that technology as developers. So the first idea which came to my mind when I saw those functions was to try to actually see what makes people happy. And we can do that because on the picture, we can detect emotions, like we can see whether a person is happy or not. And we can also detect things like age, number of people on the photograph, whether the person has facial hair or not. Maybe that is the way to become happy. You just put on a mustache, and who knows, maybe people with mustache are happier. That is, of course, not a very serious scientific study, as you can imagine, because like, first of all, a person might look happy, but it doesn't mean that he is happy inside, and we cannot really, unfortunately, up to this moment, know what is a person like feeling inside just from the picture. But it makes a nice exercise and a nice demonstration of using cognitive services. So if you want to try this yourself, I have the Python code available in the GitHub repository. And maybe I should even put this in the chat. So it's called Cloud Advocacy Phase Studies. Let me paste this in the chat for you. So this repository contains two notebooks, one in English, one in Russian, so that you can easily try them out. And to try them out, well, you probably know that Jupyter Notebook is a special way to combine code and Python code and text. So it's kind of document with executable parts. And to run Jupyter Notebook, you need Python environment. So the best way to do it probably is to have Python installed locally. So you can put on, like, you can install Python, and I personally prefer Miniconda distribution because it's very small initially, and then you can expand it if with things that you need, or like any other Python distribution. And you can use Visual Studio Code to run those notebooks inside Visual Studio Code. And that is the preferred way that I will also show you, because that's how I normally work with notebooks. Another way to do it would be to do it online. Online, there are nice service called GitHub Codespaces, and GitHub Codespaces right now it's available in the preview, so you probably would not get access to it immediately. You need to apply and wait for some time. I'm privileged to work at Microsoft. I can beg people at GitHub and they gave me access. So what it is it's an ability to run the GitHub repository inside an environment very similar to Visual Studio Code, but online in the browser. So you don't need to install anything. You just say, I want to open this with Codespaces. Then you say, I want to create a new Codespace, and that's it. You have this code running. And a similar way you can use Binder. Binder is a third-party service, which will, like if you click it, it will launch a notebook for you. So it would build a special container for you and open it inside the browser. The main disadvantage of using Binder is that you will lose changes, because it creates the environment for you just for the moment, and then at some point it times out and you lose all your changes. So it's if you are doing some substantial work, that's probably not a good idea to use Binder. If you just want to try out the code and execute a couple of lines of code, that's the perfect way to start. So here I can already run and open this code. And that is how Jupyter Notebooks looks like. It combines code, text with pieces of Python code. Okay. As I mentioned, I will be using Visual Studio Code. Of course, you also can use, instead of that, you can use Google Colab. Just take the file from GitHub and upload it to Google Colab. Okay, I will switch to my beautiful Visual Studio Code. And here is this notebook. So, because we want to start analyzing faces using cognitive service, we need the access to cognitive service. And to do that, we need to create the Face API object in Microsoft Cloud. So the way to do it is you will need a Azure subscription to do that. If you have the Azure subscription, which I hope you do because you have probably attended earlier sessions, and at each session people were telling you get Azure subscription to experiment. If you have Azure subscription, you are good to go. If you don't, you can always create the free trial if you are not a student, but you would need a credit card, or you can create the student Azure for Students by verifying your student status through university. Another good idea would be to get GitHub Student Developer Pack, which is even better because you verify your student status once, and you can get Azure, you can get Amazon, you can get all the free features that many companies have for students. So once you have your Azure subscription, let me show you what you need to do. You need to create the cognitive service resource. So you go here, you say cognitive services. Services. You say create, and you specify name, location. Like location, probably you would want Europe, so that it's faster to be called. And that's it. I will not create it just to save time. I will show you the existing resource which I have created before. And once you do that, in this resource you would see keys and endpoint. So endpoint is the address at which you can call this service, and key is the secret key which is used to like verify that that's you who are calling, so that everybody cannot call this service, because at the end of the day you end up paying for it. With Azure for Students, I think you get quite a lot of free stuff, like something like 30,000 calls to cognitive services for free during the year. And for $100 that you get in credits, you can process millions of more images, because that's really cheap. But still, I mean, it is using Microsoft resources. Somebody has to pay for that. That's why you need the key. So once you get this endpoint and key, you need to put it in the code. Like here, I have one of the first things I do. I define key and endpoint here. And you may want to remember my key and say, okay, I will use your key and I will be happy for the rest of my life. But that will not work like that, because immediately after my talk, I will change the key and it will not work anymore. So no use writing this key down or remembering it. Now, to actually do the call to the service, we can use REST API. REST API is just you are calling a service similar to calling a web page, or you can use Python SDK. Python SDK is probably easier, and that's why I installed this Python SDK. You see, I do pip install Azure Cognitive Services Vision Face. Pip install is the Python way to ask to install a third-party library. And once I do that, I can import certain object here, and to call Face API is just a function call. So you see, for example, I take this picture of myself from internet somewhere, and I call the service. I say client.face.detect with URL. I pass this URL, and I say I want to return emotion, age, and gender. And once I execute this, I get emotions. You see, anger, content, disgust, fear, everything 0 except happiness. I get age, I get gender, and that's it, because I asked for emotion, for age, and gender. You can also ask for other things like facial hair or things like that. You can ask what you want to detect. Now, how can we do some interesting things with that? We need a lot of photographs. The easiest way to get a lot of photographs is to find them online somewhere. Why is that? Because you don't need to pass the data over. So to the service, you can either pass the photograph as a stream of bytes, or you can just pass the URL, as you've seen here. And if we have photographs somewhere in the internet, we just pass the URL. We don't need to send the bytes over. So what I do, I take the website of one conference. And this conference, because I was doing first this presentation at the workshop for psychologists, because psychologists probably are interested in what makes people happy. So I took the conference, like psychological summer school, and we can see how it looks like. Oops. Yeah, because so the page of the conference looks like this. It's in Russian, sorry about that, but you get the idea. There is a photo library somewhere if you go through it. And this photo library contains pictures which have very specific addresses, like this one /photo/xxx.jpg, where xxx is the number of frame, which goes from 000 to 131. And I can, yeah, I needed to look at the web page source to understand that, but that's not a big deal. Probably you know how to do that. So I create the list of URLs, and then like here we can see what those photographs look like. We could see them on the web page as well, but in the Python notebook it's definitely cooler. A lot of psychologists on those pictures, and we want to know like what makes them happy. So what I would do, I would just run this code to process all faces of all people on all those photographs. To speed my talk, not to keep you waiting, I have already done that. So I will just download the final table. So the final table, like what I do, I process each photograph, and all faces in the photograph I put inside a table. A table in Python is called data frame, so I use pandas here. So I end up with a table like this, which contains like one row for each, not for each photograph, but for each face. That's why I have 130 photographs and 330 faces. And for each face, I have age, I have emotions, and I also have the number of faces on the picture. Because who knows, maybe that is useful. And it's easy to detect number of faces in the picture. That's why I store it in the table as well. So now we can do some interesting explorations. Like, for example, we can plot histogram of ages, and we can see how old those people are. And that is like pretty understandable distribution, because we have a lot of people who are students, who are younger, and we have some older people who are professors. So that's why we have this distribution. What about distribution of happiness? And that is also quite obvious, because you see that the network detects, like in most of the cases, a person is either happy or, well, not unhappy, but zero, not happy. And sometimes it's a little bit of happiness somewhere in between, but not often. That is how the neural network works. I mean, if you smile a bit, it means you are happy. I mean, you cannot easily determine the amount of happiness from the smile. But if you have some strange emotions, like you are smiling and your eyes are sad, for example, in this case, it will return the combination of emotions. Okay, our goal, like one of my first hypotheses, was to try to see if the happiness depends on age. So we can plot happiness against age, and we get something like this. This is not clear like what it means. It's kind of a lot of dots everywhere. So not the most clever way to do it. Okay, let's start with the easier problem, like who is happier, males or females? How can we know that? We can also plot something like this. We can plot like gender against happiness. Oh, do we have gender? We should. Yeah, gender is not a number. That is the problem. So we'll not do that. So what we can do, like to be more clever, we can group everything by gender, and then compute like mean happiness, average happiness across genders. And this will give us this picture. You see, males are less happy. Does it mean that is the case? I don't know. You can argue there could be many different reasons for that. Maybe that males just don't smile as often. Well, we can also plot, like, for example, against number of faces. We can group by number of faces, and we can see that more people are there on the picture, the happier on average they look. And that is probably because everyone likes to smile on the group photo. And if somebody is photographed like without noticing, without letting him know, he might be like caught in the unsmiling state or something like this. Now, against if we come back to the age, if we plot against age, it's not really clear like this because there are many different possible ages. We probably need to define some age groups. Like if I do like divide by 10 and then multiply by 10, so it will be like age group, teens, 20s, 30s, and so on. It would become more clear that people with age become less happy. And if happiness decreases, something should increase. So if we plot sadness against age, we can see that, yeah, old people are really sad. And there are also a lot of other things we could compute. So you can run this processing on any of your own pictures. Like here, the second part of this actually runs it on the pictures which are in some directory. So here, inside images directory, you can put your own pictures. And it has some advantages because if you put your own pictures here, you can also extract the face itself and have a look at it. So for example, here what I do, I do like similar analysis, but I also try to find the most happiest, the saddest, the most surprised face, and so on. And you can see how they look like. It's interesting to observe. Happiest faces looks a little bit strange to me, but somehow. It's also interesting to find the face with the most mixed emotions. Like here, I look for the highest second emotion. So for example, this face is at the same time happy and surprised. You see, it's a kind of strange emotion here. But then we can ask us some more interesting questions, like are there combinations of emotions which are typical? Like, is it typical to be happy and surprised at the same time? So we can take those vectors of emotions and try to group them somehow into clusters using scikit-learn, using some data science technique. So here what I do, I ask scikit-learn to cluster all emotional vectors into 3 categories, and then display those 3 categories. So you can see there is clearly happy people, also clearly happy people, and some very strange combinations of emotion: happiness, sadness, and surprise. This is probably because the face is blurry, not because people sometimes look like this. But are there any other photographs from the same cluster? This is cluster number 1. So we can just take images from cluster number 1 and see how they look. So like all those, they probably look a little bit small to you, but all those faces, they show this kind of strange combination of emotions. Well, not exactly this, but close to this in the same cluster. So that is, I think, an interesting example which shows that you can do sometimes unexpected things. Like you can use this service to extract additional information from images and then try to use it in some other studies. Now, let me go back to the presentation. That was the first example that I wanted to show you. And the second example is connected with art. So my second idea, you have seen that Face API gives us facial landmarks. It returns us the special points in the face, such as pupil coordinates. And what we can do, we can take a bunch of photographs and we can align them automatically in such a way that eyes occupy the same position. And if we do that, and if we have a lot of photographs, you can see that it kind of blends all the environment together, but eyes are clearly visible. That is because they are all at the same point. And this gives us the ability to create this kind of strange looking averaged portrait of a person, which I call cognitive portrait. In fact, that can be considered a direction called science art. Science art is a very interesting field when you use code to create some works of art like this. And artists, they use sometimes their own specific tools. Like one tool that I think might be interesting for you to know about is called processing. Processing is the language. It's based on Java or JavaScript, kind of Java-like language, in which supports like direct text drawing commands. So it happens that with this language, it's pretty easy to create kind of drawings and graphical creations. To give you an example how it looks, processing has its own IDE. So it looks like this, and it has Python mode. So you can, from the processing side, you can get it. It supports Java by default, but you can also install this Python mode, and you can do development in Python. So you see, this is pretty simple program which I took from Open Processing and converted from Java to Python. And this code creates something like this. I hope you can see it. It's kind of random. Let me start it again, because this random combination doesn't look too great. Yeah, it creates those kind of random circles, moving circles, which I find pretty fascinating to look at. And all that is created by a small piece of Python code. So there are a lot of people who actually experiment with processing, and they create different nice things using this tool. And there is a site called openprocessing.org. On open processing, you can see what other people are doing. Like here, there are a lot of examples. You can open, for example, this one that I had on my page as a screenshot. You can open it, and it will start drawing this kind of mess, which will then look as a picture. But you can also switch to the code at any point and look at how this was done. You can modify this code and make your own creation based on this original one. So a very good way to collaborate for people who do science art. But for us, we will do something different. We'll do this kind of combination of photographs together. So again, idea, I take photographs, I extract facial landmarks, I align it in such a way that eyes occupy the same position. So let me do that I will switch back to Visual Studio Code. And yeah, let me show you the repository. I have the repository here, which I probably also copy now to, sorry about that. I will copy it to you, to the chat, so that you can also enjoy it here. And that's how it looks like. No, not this one. This one. So it's again available in English and Russian. So in case you read Russian, you can take the Russian version. And it's the same mechanics here. You have the Jupyter notebooks. You can start them in Binder. You can open them in Visual Studio Code. So here we have this notebook, Make Art in Visual Studio Code. We start again with putting the keys and endpoints. And let's make sure that everything works. Yeah, here with the same function call, instead of age and other things, we extract facial landmarks, and we get this kind of collection of coordinates. So now you need to upload your own images. Like if you do Binder, you need to click in the web interface to upload your pictures. If you use Visual Studio Code, you just put them in the images directory. So for me, I put the photographs of myself and my daughter to create something. To create something in between me and her. If you put photograph of different people, then it combines them and comes up with kind of average face. If you put photograph of the same person, of course, you would get averaged photograph of one person. Okay, so now here we have the code. So what I will do here, I will define the function to load the image, and let's load first image and analyze it and plot the dots over the face, just to make sure that it works fine. You see my photograph, and those are all facial landmarks that I have extracted. So now what I can do, I can run this through all the images. I think I have done that already, so I will skip this piece of code, but you will run it. It takes only 20 first images because in case you are using free cognitive services, it has the limitation of 20 calls per minute. So it's always easy to limit the call to 20 photographs. Yeah, yeah, and probably that you don't need more than that, because if you put together more than 20 photographs, it becomes like too messy. Okay, we can show how those images look like. I just write a small function to display images and take first 5 images and show them. Here they are. Good. So next, I have extracted all facial landmarks from them. So I need now to transform the image, to rotate it in such a way, well, not only rotate and zoom and do all other transformations in such a way that faces are in the same location. So that can be done using a thing called affine transformation. Affine transformation is the way to transform image so that like parallel lines stay parallel. So it's not distorting your geometry of your face, but it kind of zooms, rotates, and like shrinks the photograph so that eyes are in the right position. And the affine transformation can be defined by 3 points. So you need to define 3 points originally, and where those 3 points move. So I take 2 points are coordinates of eyes, and the third point I can take anything else which is not on the same line. So I can take, for example, left part of the mouth, but that would be kind of non-symmetric. So that's why probably it's better idea to take the middle of the mouth. And middle of the mouth, there is no point like that. So I calculated by averaging mouth left and mouth right. There are 2 points which were extracted by cognitive service. So I average them, and they say the left pupil should move to this point, 130, 120. And given that the final image should be 300 by 300 pixels, it's kind of where the eye should be. The right eye moves to this point, and the middle of the mouth moves to this point. So all of those 3 points are now becoming fixed. So if we run this through all of our images, we will see in a second that they are all aligned. You see, all the faces are in the same kind of central piece of the photograph. So now we just need to merge them, and that's easy to do because in Python images are represented by arrays, by NumPy arrays. So we just need to call the min function. But I want to be a little bit more complicated. I want to be able to assign weights to different images and randomize them to create slightly differently looking results. So I create the special function to do merge. Now here is how 2 photographs are merged together. You see, well, I mean, I look very similar at both of them, but yeah, you can see that they are merged together. And if we merge all photographs, we will get something like this. This is me and my daughter. Looks a little bit scary, unfortunately, but don't know why. I can also like try that several times with random weights until I get nice result. You see, they are slightly different, and I can run this many times until I am satisfied. So that's how you do those cognitive portraits. You can then save it, of course, to the image file and do whatever you want with this. If you want to print it, like I think for the last New Year, I printed out the calendars to my friends with their portraits. I took the photographs, I think, from Facebook or from my own photo collection, and then made them in this kind of New Year present. If you want to do that, you might want to make them high resolution. To make them high resolution, you just need to adjust this size, and you need also to adjust the coordinates, of course, proportionally with the size. So that's how easy it is to draw this cognitive portrait. And you can also do some more interesting things with this. So for example, what you can do, you can create photographs like this. This one is called growing up. It shows my daughter the process of her growing up. So I took her photographs from my family album. That is one of the reasons I needed to do face detection, because I automatically detected all photographs with her. And then I put them into several categories according to the age and aligned them in this way automatically. So all this picture was just produced by a piece of Python code from my family album. Well, 2 pieces of Python code. First one like did the processing and created a kind of database, and then the other one took the photographs which I need, aligned them together, and produced the result. So I think that's a really good tool for artists, because you can create many different interesting ideas with this idea of being able to extract facial landmarks. Like you can create, can separate out somehow, like fade out the everything but the face. You can do many different ways with code. And if you want to spend some time playing with that, I have another GitHub repository. Let me switch to the browser and show it to you. So this one, DJ Art for Teens, that I have shared with you originally, it's a simplified version. It contains just this one notebook with cognitive portrait. But there is also one more, which is called Cloud Advocacy / Cognitive Portrait, and that contains different. I will share it with the chat in the chat as well. So it contains different ways to join photographs together. Like in addition to the original one, you can do like this circle with faces. You can do triangle. You can like do many other things. And those some of those were created by other people. Like some of them are my students whom I asked to do that, and they do pull requests, and that's how we get more interesting ideas here. So if you play with this, and if you come up with your own way to align photographs in the interesting manner, please do a pull request so that we can see what which original ideas you had in mind. If you just want to to play with the results, like if you want to create the photographs of your friends, what you can do, you can use the bot. I have the chat bot in Telegram, which is called People Blender Bot, and you send a photograph to this bot, and this photograph is being automatically mixed together with other photographs by from other people. So like if you're having a party, you can ask everyone to send pictures to this bot, and you will get the blended photograph out of it. But you just need to do it at the same time, so that it takes only your photographs and not those of somebody else. It takes, I think, last 15 photographs or something like that. Another way to do it, you can also this is the strange link, but I will show you the I will paste the link into the chat again. This is the web page, which will allow you to take photographs right from the web page, and you click a button, and it automatically creates a portrait for you from your photographs and 15 other photographs of other people. So both bot and this page is powered by the same backend, by the same cloud backend, so they are mixed together all of the photographs. Okay, so that's I think that was a very useful exercise in using Face API, and it shows us that AI can be really helpful in creating art. And in our case, we used AI because extracting facial landmarks is done by a neural network. But the interesting question is, can artificial intelligence create art all by itself? And it looks like in some ways it can, because there is a technology called generative adversarial networks, which can produce the pictures like this. You can see the pictures of flowers, of landscapes, even portraits. And the way those pictures are produced is that we take 1,000 or so of paintings, and then we train the network to generate those pictures. And the way this network is trained is by like it's called generative adversarial network, because two networks are trained together. One of them tries to create a picture, and another one tries to tell whether it is fake or not. And by training together, those networks learn to mimic human style of drawing. It's an interesting question whether you can call this art, and whether this has been created by AI or not. You can probably understand that those pictures are cherry picked, so they are selected from a number of examples produced by the network. Some of the results produced by the network are not as beautiful, of course. So there is quite a lot of human involvement in this process as well. But what artificial intelligence does, it extracts patterns. You see, it's very good at extracting the low-level canvas, like the canvas structure, the texture of canvas. So it's in all pictures, you can see it clearly visible. And it's also good at extracting the high-level patterns, like how the face looks like, that the face contains eyes and those kind of things. It picked that up from real paintings. And then what it does, it randomly combines those patterns to produce this result. Sometimes the painter, the human artist, does the same. Like, you know, many, like not many, but some of the artists, what they do some randomness. You know, they spill paint on canvas in a random way, and then they try to paint something around it because they need some kind of randomness for inspiration. So definitely this AI can be used as a great starting point as an inspirational starting point for the artist. And the discussion whether AI can produce art and whether it will own art or not is an interesting discussion. So you can read more about that. You can think for yourself and try to see if you agree with the fact that AI can produce art like human being. And if you're interested to know my opinion, I have my own. I have a blog post on that, so you can have a look after this session. I will also send you the link in the chat. Okay, I think that concludes my talk. If you want to see some more pictures produced by a neural network, you can subscribe to the Instagram Art of Artificial. Sometimes I try to post there something new, but not often. But yeah, if you subscribe, you will see there is a bunch of pictures already there. So in any questions, please feel free to ask them in the chat. The first question, will I share the slides? Will we share the slides? I think we will. I think we will even share the recording.
Great. Dmitry, thank you so much for an excellent session. It's been so interesting, and thank you for showing us everything that you've been working on. We do still have a few minutes, so if there are any questions, feel free to send them through now. But yeah, Dmitry, as you mentioned, we will be sharing the recording from today. Actually, let me send the link out to you now where you'll be able to access that. So it should go live within the next couple of days.
For the presentation, I think I would like to change a few links there, and then I can post PDF to my speaker deck. I always use speaker deck account. I will share with you the link as well. So if you check there, like also in a few days, then probably you will see the presentation as well. And you might also find the similar presentations there, because I think that's not, I've done similar talks before as well.
Great. So we have a question from Karen that's come through asking if you created all of the algorithms.
Excellent question. So no, I do not take credit for creating everything. So what I showed here is the cognitive portrait example. The cognitive portrait example, it was my idea. I created this notebook, which I have shared with you. But we are using the cognitive service, which was, of course, developed by Microsoft. And for neural networks, like for the pictures that I have shown you, the algorithm is pretty well known. Like generative adversarial networks, they are known for like I think 3 or 4 years now. And well, I have produced those paintings. I have trained this network. I have developed my own version of generative adversarial networks, but based on some existing code as well on GitHub. So it's not like a know-how. It's not like an original algorithm to do that. It's pretty well-known technique among people who are doing data science and artificial intelligence. But those, I trained those networks, and those were trained, I think, 11 hours on GPU machine in the cloud, 11 hours for each of the categories, like for portraits, for flowers, and for landscapes. There is a question that each object obtained from neural network had soft clustering. Is it obtained through Gaussian distribution probabilities or using different distributions? Yes. Well, original distribution, because the way those images are obtained is that they receive the random vector as an input, and random vector was normally distributed. That's true. I'm not sure like how this affects the final way the images look. I guess one of the reasons they look like this is that they are pretty low resolution, because those I think are 520 by 520, and generative adversarial networks, like in a simple form, they do not produce the good high resolution images. So we need to train in a more complicated manner using progressive scaling, and that is something I have not done yet, but you can do that. There is a question if there are any upcoming hackathons or competitions for high school students in US, especially during summer. I don't know, Emma, if we know that, because I personally do not know out of my head. But I think a good place to look for hackathons would be Major League Hacking. And Major League Hacking is an organization that kind of supports hackathons in different universities and schools. So they act like an umbrella organization, and you can see they have probably a schedule of the upcoming events on their websites. So I think the website is, let me double check, it should be mlh.org. No. mlh.io. I remember they have a nice name. So that would be a nice place to watch for a hackathon.
Brilliant. Yeah, off the top of my head, I can't think of any that are being run out of the reactor, unless there's maybe something coming up on one of the meetups, so I can post a link in there, so it might be worth just keeping an eye. Let me get a link. And then just a reminder to everyone as well, I just pasted it into the chat about the certification voucher giveaway that we're running throughout this series. So to be in with a chance, you just need to check in for each session that you attend, and it needs to be a minimum of 4 out of 8 sessions that you attend. So all the details are just in the chat there that I've pasted.
What I will also show in the chat is that I have the blog post describing more the idea of this cognitive portrait. In case you want to learn like a little bit the same thing, but in a slower manner, you can read it as a part of blog post.
Great. I don't see any more questions coming through.
Good. Thank you so much for attending. I will probably drop off because I have another presentation in 5 minutes. And yeah, it was really nice seeing you all.
Great, Dmitry, thank you so much. I'm looking forward to your next session with us next week.
Yeah, by the way, next week is also going to be very interesting. Please come.
Yes, absolutely. Yeah, you can sign up now. Same links that I've been pasting into the chat, and they're available there. So yeah, really looking forward to that. Same time, same place next week. Dmitry, thanks so much for today, and thank you everyone for attending, and hope to see you all back again next week.
Thank you.